Okay, we're starting with number 21. Select all relations that represent a function. Remember, a function has no repeating x values. No repeating x values. So do any of these repeat? This one does. So that's a nope. This one, any of my x's repeating? Ooh, that's a good one. Vertical line test. Does it hit it twice? You're good. This one is a yes. If it's in slope-intercept form, we are good. That's linear. It looks like that. You could graph that one. And then E. What do you think? If I do a vertical line test, it hits here and here, so this is a big no. So B, C, and D. Next. So here we have these two graphs. So if you are going from here, and again, remember just y equals. Change that f of x just to y equals. And this one too, y equals x squared plus 5. They're two different equations because this is the g and this is an f. So select the word that correctly completes the sentence. The graph of g will be shifted. So what changed between this graph and this graph? If you put it on Desmos, you will see, again, it's in that format, a x minus h squared plus k. That's my plus k. This is my constant at the end. So it's going to tell us to move up 5 units. That one was easy. Love it when they're that easy. All right, so let's think about these. These are going to be, some of them are harder than others. So if we look down here, what are we doing? We are dividing by 2. So dividing by 2. Here, it looks like a reflection like that. So what do we do here? We decreased by 2. We increased by nothing, and then we increased by 2. Here, I know you're saying this is a pain in the drain. So you're basically, 9 over 2. Don't freak out because you have a fraction. You have a calculator. So what is 9 divided by 2? Let's just make that easier. This is 4.5. So what are you doing? You're increasing by a half each time. Increasing by a half. It's constant. How about this one? So I always kind of look between like ones I know. So to get from 1 to 2, I'm either adding 1, but I'm not adding 1 here. So let's go the other way. 2 divided by 2 is 1. 1 divided by 2, obviously this is a half divided by 2. So, but going this way, we must be multiplying by 2. All right, so this is how this works. So 1 is a quadratic. So the quadratic is the one that's like a race car. It is a, what do you call those? You say them frontwards and backwards the same way. Oh, what is that word? I can never remember it. Anyway, so as you can see, 3, 1, 1, 3. It's giving you that parabola. And believe me, you can graph these points. If you graph these points, all of these things on your graph, if you're dividing, then you're going to have exponential. Multiplying or dividing, you're going to have exponential growth. Let's see here. Which one do I want to start with? Repeated adding is linear. So which one? I'm trying to think of what we know the best. So linear, and this one was repeated adding, which was h of x. So that's this one. So this goes here. Quadratic, like I said, if you would graph these as ordered pairs, say graph -1, 3, 0, 1, 1, 1, 2, 3, you can see what that looks like. So that would be quadratic. So that is g of x. Okay, so that one's okay. Exponential growth and exponential decay. Well, decay would be getting smaller. Growth would getting bigger. K of x is multiplying by 2, so it is getting bigger. So which one? Okay, so he's going to go down here. This one, since you're dividing, it's getting smaller. It's going to go over here. So that's what the difference would be. Okay, next. Okay, we've got this nice trend line here, number of days missed, and they're great, so we should know some of these things. Select all that is true. So the number of days missed has no correlation to a student's final exam grade. Well, that's false. There is definitely a trend there. A student with perfect attendance, so that's perfect attendance, is no days missed, is expected to score 98%. So what do you think that score is? 98%? I'm saying that's true. A student with perfect attendance is expected to score 38. That's false. For each day a student is absent, the student's final score is expected to decrease by 6%. So let's take a look. Let's find a point. We can use that and follow this along. And where's another point? Ooh, here's a point. Do I want to find another point? So from 1 here, is he going to lose about 6 percentage points? So are we completely going down by maybe 6? Going down by 6? Okay, could be. That seems kind of true. Let's read this next one. For every 6th day a student is absent, the student's final exam score is expected to decrease by 1%. That one's definitely false. So here's our 2 true statements. Next. On these, I would totally graph them. So on Desmos. So hopefully when you graph these, and I don't even have to make a real life big deal of a graph. So I'm going to graph these here first. So 2, -1. I really want to do this on Desmos, but 2, -1. 3, 0. 4, 3. Okay, 1. Do you like how I did nothing? And then 0, 3. Ooh, you've got this nice parabola. Okay. This one here, I can make a table of values. It's hard to remember, so I would do this in Desmos. So I'm going to do this quickly in Desmos. So I'm going to Desmos. You guys obviously should be very familiar with Desmos. You will be able to use Desmos and graphing calculator. And I am going to put x squared, and use the caret key if you don't know how to do the squared, minus 2x minus 3. Okay, so on that I can get some points. Or I can just look at it. I know my vertex, which is this point here, is 1, -4. Okay, so I'm going to make my own graph. So 1, -4. We'll just put it here. The next one is 0, -3. So 0, -3. This one is 0, -1. This one is going to be on the other side, so 2, -3. And then this one is going to be 3, 0. Okay, so let's compare. Now that we've done both of these and we know what they look like, so which function has a minimum of -1? So which one has a minimum of -1? Well, obviously, it's g of x. I'm going to label these. G of x, and this is the f of x. Okay. So g of x has that. Which one has a minimum of -4? Remember, this was 1, -4, so that's my small minimum, this guy. Which one has a 0 at -1? Now, what you need to understand about these zeros, it's where it crosses the x-axis. So at -1, we know it is this point right here, so that's f of x. 0 at 1 was g of x. 0 at 2, did either one of them have a 0 at 2? Neither one of them did. 0 at 3, that would be g of x. And that's how you do that. So you're just answering the questions. Make sure you understand that 0 means where it crosses x. Sometimes they call those the roots. Minimum is the lowest value. And you're talking about lowest y value. Okay? Wasn't so bad. And love the Desmos. Okay. Here's another thing on Desmos. You can graph these as ordered pairs on Desmos, but let's just take a look at these patterns. And that's what you need to take a look. So a linear function means repeated, add, or subtract. Oops, I can't spell subtract. Okay, so am I decreasing by 3 the whole time? Yep. Is this the same? Yep. How about this one? This looks like I'm dividing by 3, so that's a no. This looks like a yes. B, what am I doing? I'm multiplying by 2, so that doesn't work, so that's a no. This one, I'm increasing by 1.5, so that's a yes. This one, I'm increasing by 4. Is it constant? So yes. And this one, I'm increasing by 3, and then I'm increasing by 5. Oh, so that's not going to work. So it's got to be the constant, repeated adding or subtracting. On to the next. Let's graph these babies. Ah, this is easy. You can do this on Desmos or on your own. Again, these are all in slope-intercept form. So my y-intercept is a +3, and I need to get my glasses on. Oh, gosh, that's annoying when it's between. I think they do that on purpose, so we have to struggle. And then down from a +3 would be 1. Okay, I'm at a +3, and I need to go down 2. So down 1, 2 over 1. Okay. So I would need a straight edge, definitely need a straight edge to connect those. And you can kind of see, let's see if I can go down 1, 2 over 1. Super annoying. You might want to graph this on your own paper that you get, your practice paper. Might be easier because I believe you can make yours go up by 1s. This one is start at -2 and go up 1 over 1, 2. Up 1 over 1, 2. Super, super annoying. Do you love it when your teacher says that? Okay, so where do they intersect? It is really hard for me to see this on here. So I think I'm going to do it on Desmos and see, and you can do the same. So graph those 2 points on Desmos, and where they intersect should be 2, -1, because that's what we're looking for. In a system, we're looking for that intersection. Next, All right, we're looking at correlation causation, and we hit this a little bit. So let's do all of our lines of best fit. Okay, it's good if you have a ruler that you can kind of see through, so you can see that you have an equal number above and below. Doot. This one. Negative. And this one has really not so much. Not much. Okay, and let me explain to you these values. So you're either at a 1, which is great. 0 is none. -1 is great, but negative. Okay, so if I look at this one, that's really good. Everything's tight. We're positive. So it's positive. So which one of these is great, almost great? That would be this one. So he's going here. This one is also going positive, but it's not great. It's not great. The dots are not close to our line, and the dots are just all over the place. So he's going to go here, but it's positive slope. Here, this one's pretty good. So which one is closer to negative great? This one here. And then this guy is so close to 0 because there's really not much there. And that's how you do those. It's great practice. Not hard, but great practice. Is that it? Did you guys have another one? Did you? This landscaping thing? Tony is re-landscaping. Yes. I don't know if we're going to have any of these, but we'll try. Tony is reseeding the lawn that covers 2,500 square feet, and grass seed is $15. Okay, so these two things go together. So $15.98 for a 7-pound. Okay, each pound, so 1 pound, covers 150 feet. Okay, so we need to get to this to be 1 pound. All right, and then how many? We have 2,500 divided by the 150 square feet. Clear. 2,500 divided by the 150. I need about 17 bags. Can't go 60, it has to go 17 because you wouldn't have enough, right? You need 17 bags. You could think about 7, right? We need to get this to 1 pound. So this is 1 pound, 1 lb. Okay, so if I cross multiply, basically all you need to do is say 1598 divided by 7. So it's $2.28 per 1 pound. Okay, and I need 17 bags. So I'm just going to take that and multiply it by 17, and I get about $38.81 or 80 cents, something like that. How much will it cost to reseed? Enter the cost of the work in the box. Each pound of grass covers this. I'm going to need 17 bags. I did this differently last time. So I feel like I'm not doing this right. Because it comes in 7-pound bags. That's why. Okay, So if I have 17 bags and I divided, and I need this, comes into 7 bags, 17 divided by 7, he'll need 3 bags because you've got to round that up. So really it's 3 bags times the $15.98 because you can't buy it for 1 pound bags. So that's where you really have to think if your answer makes sense. So you're going to take 3 bags times $15.98, and that would be your total. Did you guys have another question, or was that it? Okay, I think that was it. All right, please, 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 I hope you understand that. I hope it helps. I want you to work through the practice test so you can understand the tools, enter the correct answers, make sure you know how to use the Desmos. Do it, do it, do it.